What's going on, everybody? This is Mr. Diamond, and we are here at, I guess you could call this the final stage of this chapter. This is all just the naming practice, bringing together all of the stuff that we have talked about. Our carboxylic acids, our acid halides, our alkyl halides. And on top of that, and on top of that, we've also got our R and S, we've got our E and Z, we've got our cis and our trans, we've got all of that stuff going on in all of these problems. They are all on the table just in case, or don't feel like you have to use all of them for every single one, but they could show up on any number of these problems. So we're going to start with the easy one over here. I do already have I have a methane, or I have a carbon with 4 bonds attached to it. I also have my 4 colors over here. I have my green, purple, my red, and my blue. I also have my pens. I have my green, my blue, my red, and my purple. So I'm going to be using that same strategy that I mentioned in the other video. You don't have to use it, but I really feel like it helps. So I would really recommend doing that. Again, I know I'm just in the pocket of big colored pens at this point, trying to make you guys spend more money, but they are super helpful for this. So let's start by looking at this left one. I'm going to draw it a little bit bigger. It's slightly different than the one that you guys may have seen in the notes slides already, but I wanted to include some other stuff to make sure that I've done some more examples of it. So we've got this, and then we're going to go up, down. We've got a wedge here, up, down, up. We've got some dashes here. And we've got a CL right there. Okay, so we've got 2 possible, and I'm going to say this now. I think all of them are going to be needed on these set of examples here, but just because I draw this, I might be trying to trick you, or the structure might be drawn that way, but you may not actually need that. So double check and make sure every time you see this that you are actually going to have a chiral carbon there, that you are actually going to need to do an RS stereocenter. So in this case, I've got a methyl group here. I've got a chain over here that's different than this chain over here. My last piece is a hydrogen, so I will actually have a chiral carbon there. I have a methyl here, I have a chloro here, and then I have a chain here, and I have a hydrogen there. So those both are, in fact, chiral, and same with this one right here and this one right here. Those are also chiral. And that's usually how I like to just note them, is I like to just make them a little dot so I can kind of clearly remember that they're chiral. But I'm now going to also go ahead and add in, just really quick, I'm going to add in a little dash, and I'm going to add a hydrogen. And I'm going to add a little wedge. And I'm going to add a hydrogen. Because I want to know that that's where they're at. I want to make sure that I remember that those pieces are there. So let's go ahead and use all of the information that we've used up to this point. So I've got 1, 2, 3, 4, 5, a 6 carbon. That's a hex. There's no double bonds, so it's a hexane as its base. That's its root. It's got a 1, 2, 3... because this is the first position, we'll number it. It's got a 3 methyl that needs an R or S. And it's got a 1, 2, 3, 4, a 5. And remember, for these, we can just treat them as functional groups because they aren't the actual, they don't need to go at the beginning. So this would just be a 5 chloro. And again, we don't need any monoditris for that because, well, if it's 1, we don't need mono, and then there's only 1 of them, so we don't need di or tri for it. But if you would use those if there were extras in there. And then on position number 1, we've got, this is a carbonyl carbon and an alcohol together. A carbonyl carbon and an alcohol together is a carboxylic acid. So it will be 1. There is a carboxylic acid. And the ending for that, which I'm a little rusty on because we added these, we didn't do these last year, is an oic acid. And you'll notice that in the examples I've used, you've never needed to actually add a number with that. And that's because you will only ever be putting it at the beginning. Because it takes 1, 2, 3 things for it to be there, it's got to be at the first position in your carbon chain. And the only other option would be if it was at both positions. So if it just said dioic acid, you would know there would have to be one over here, and the other one would have to be at the other end of that chain. So those are the only ways that they could be positioned, so there usually isn't going to be a number associated with them, unless I'm just really paranoid that you're going to get something wrong. Okay, now we need to identify our stereocenters right here. We need to figure out if they're R or S here, and we also need to figure out if this one is R or S. And to do that, we're going to need our little friend right here. So let's go ahead and do our ordering here. I've got my same rule. I'm going to go in the same sequence I did before. I'm going to use green as lowest priority, and for both of these, our lowest priority is going to be our hydrogen. So I'm going to go ahead and start with my first one, and I'm going to put hydrogen going back. I've got this is going to be coming down. This is going to be my next lowest priority. This is a carbon attached to a carbon. This is a carbon attached to a carbon. This is a carbon attached only to hydrogens. So that's going to be my next priority. So that's going to be blue. So I'll put a little blue line there. I know that one's not going to be super easy to tell that it's blue, but I'm going to go ahead and add my blue carbon piece, or my blue molecule piece right here. Then I'm going to look at my next ones. So this is a carbon, this is a carbon, so those tie. This carbon is attached to a chlorine, a carbon, and a hydrogen. This one's attached to an oxygen, an oxygen, and an oxygen. Even though that's 3 oxygens, so let me actually list that out here. So this one here is attached to an OO and a O. This one's attached to a Cl, a C, and an H. So going from this direction, tie, this position here is ClCH. This is OOO. Even though those O's beat the C and the H, you go to the first, the very first position of difference, and chlorine is a higher priority, which means even though these are almost identical, even though this has a whole bunch of oxygens here, that first chlorine beats that first oxygen. So this is going to be our highest priority group. So that one's going to be purple. And this one's going to be green. So purple is going to go, or red, sorry, not green. So purple is going that direction, red's going that direction. I have my hydrogen going back, I have my methyl going up, I have my right side of the chain going this way, I have my left side of the chain going this way. I orient it so that my lowest priority, my hydrogen, is going backwards, and then it goes 1, 2, 3, 1, 2, 3. So this is a clockwise pattern. This is a clockwise orientation, which means that this methyl is in R configuration. It's going to go to the right. Now we take everything apart. You don't have to take everything apart, actually. Technically, you only need to take 2 of the pieces off, but I want to start over from the very beginning over here. So H, lowest priority, going to the back, going to position that, or going to the front. We're going to position it like this. Cl is dashed, and I know Cl beats all of my other priorities over here. So Cl is going to be purple, and that's going to go to the back. To the right is a methyl, to the left is a long chain. Methyl. Did I use the wrong colors for this? I think I used the wrong orders. My bad, everybody. This one should have been red. This one should have been blue. So let me back up there. I apologize, everybody. Okay, let's double check and make sure. Red, purple, blue. Okay, so apologies that I did that incorrectly. I used the wrong color. Again, I picked this up from someone last year, so mea culpa, my mistake. I'm not super used to doing it with this color thing, so I apologize for that. But with the correct order of colors, so this is green, that's the lowest priority. This one is red. That's the second lowest priority. Second highest would be this one. This one's blue. Highest in this case would be this one. This one's purple. So it's green for the hydrogen, red for this group, blue for this one, purple for this one, green for the back, red for this group, blue for the left, purple for the right. So now it's actually not going to be R. It's going to be purple, blue, red. It's counterclockwise. So it is actually going to be S. Again, I apologize for that. I'm very sorry. Please forgive me. I know this is already confusing enough without me having to make a simple mistake like that, but I can't quit recording 10 minutes into the video like that and just start all over. Okay. So chlorine is going to definitely be our highest priority. Hydrogen is definitely going to be our lowest priority. This here is a methyl, which means it is our next lowest, which means it is going to be red. Okay, hydrogen going to the back. Chlorine coming to the front. Red will go up here, and that means blue must be this group right here. Orient it so that green is pointing to the back, or the lowest priority is pointing to the back. Purple, blue, red, purple, blue, red. This is going to the right, or clockwise, so it is an R configuration. Okay, with that mistake I made in the middle there out of the way, we are now good to go ahead and get our name assembled. So first thing, our ending is going to be hexane. So this is going, I haven't done this in a while, but I've noticed some people were struggling on this, so we're going to go ahead and go back to this a little bit. So this is going to be our number 4 piece. Our last piece is going to be that. And this is going to be our number 3. Every functional group that is not just one of these halides is always going to be the very last thing that you write. Then right before that would be any enes, any alkenes, or any double bonds. Then right before that is any parent chain information, and then before that in alphabetical order is all the rest of the stuff that's attached. So these guys are right here. Next I've got chloro and methyl. Chloro alphabetically comes first, so it's going to go there. But out front you have to indicate stereochemistry, so we're going to go ahead and in numerical order out front, we're going to go ahead and put a parentheses. We're going to go 3s, comma, 5r, close parenthesis. Then we're going to go 5 chloro dash 3 methyl hex an, but you don't add the E. We're replacing that E with the hexanoic acid. 3s, 5r, 5 chloro, 3 methyl hexanoic acid. All right, so there's our first example. I'm going to go ahead and pause the video really quick, and I'm going to redraw this second one down here so you don't have to watch me do that. All right, welcome back. I have redrawn this. I guess I say welcome back, but you just saw it stutter pause for a fraction of a second, and then I was instantly done. We've got our second structure here. I'm going to go ahead and disassemble my structure. Going to go ahead and do that. Okay. Now, same thing as before, using the same colors. Hopefully I get the order correct this time without having to go back and correct myself. Let's go ahead and just start listing out the stuff we've got. So we've got a 1, 2, 3, 4, 5, 6, 7, 8, 9 carbon chain. Just to double check. This one was obviously going to be numbered from this direction because it has a functional group on position 1. But just to double check, this has a functional group on position 2 from this direction or position 3 from this direction. So we're going to number from this side. I didn't number last time, but 9. So it's but it's not ane because on position 3, there is a double bond, and that double bond specifically is a trans double bond because it's entering and exiting from opposite sides. So again, remember, you've got a lot to keep track of on this one. Okay, we've got on position 2 and position 7, we've got alcohols, so that's diol. And then on position 2 and position 7, we care about whether or not it is R or S. And then we've also got on position 5 a methyl ethyl that we care if it is R or S. Okay, so that's a whole lot. let's go ahead and start identifying our stereochemistry. We need to first be figuring out our R's and our S's. So I'm going to go ahead and we'll do just numerically, we'll start with number 2. So I've got my hydrogen. And I'll go ahead and add that here. So that is a stereo center. That is a chiral carbon. That's a methyl group there. That's a hydrogen. That's an alcohol. That's that. This one's also got stereochemistry. I'm going to draw a small wedge and draw my hydrogen. Now, I normally, when I would be doing this in my head, I would not actually be adding this hydrogen, but I'm just trying to make sure I cover all of my bases for each of you guys and girls and gender nonconformings that I've got out there. So I've got all my H's identified. All of these are, in fact, chiral carbons. A ethyl, a chain, and a different chain, and a hydrogen. An alcohol, a hydrogen, a chain, and a different chain. So all of these are actually chiral carbons. We do need to actually identify R or S configurations for each of them. For all of these, our lowest priority is our hydrogens. I'm going to go ahead and highlight all of those in my green real quick. I know it's hard to tell, but that was all green. Starting with this first one. Our alcohol is obviously our highest priority because O is bigger than either of these carbons. This is a methyl, so that's attached to a hydrogen, a hydrogen, and a hydrogen. This is attached to a hydrogen, a carbon, and a carbon. So that's going to be our next highest priority. So we're going to have this side is blue. This side is red. So put my green facing back. This one's actually even going to be built in exactly the right configuration for me. So I'm going to have my purple going up. I'm going to have my blue going down, and I'm going to have my red going to the other direction. So I've got alcohol coming up and out. My methyl group is going down here, or it's not a methyl because it's a part of the parent chain, but this methyl group based on this chiral carbon, that methyl is here. My long chain would go this direction. My hydrogen would go back. Purple, blue, red. That is an R configuration. Okay. Next, and I mentioned this last time, I'm going to actually go ahead and prove that to you right now. Really quick, you don't need to, like I said, disassemble the whole thing. If you want to, you could just always have 2 of the pieces on there. It doesn't even matter which 2, and because the only difference between an R and an S configuration is 2 pieces being flipped. So I'm just only going to add on my blue and my red here. Okay, numerically next is my 5. So I've got my hydrogen going back here. Going this direction, we have a hydrogen, or a carbon, and a carbon. That's all a tie. This carbon is attached to a carbon, a hydrogen, and a hydrogen. This one right here is a carbon, a hydrogen, and a hydrogen. This one here is double bonded, so that counts as a carbon, and a hydrogen. So that one is actually going to be our highest priority. That one beats out all the rest of them. So I know I'm going to have my purple going up that way and my green coming out based on what I've got so far. And then from here, this one's attached to a carbon, hydrogen, hydrogen. Or this carbon's attached to a hydrogen, hydrogen, hydrogen. This carbon's attached to oxygen, hydrogen, carbon. Hands down, that one beats out the other one. So this guy beats out this guy. So red is going to be going back because, again, it's a dashed line. Blue is going to be going up. Rotate it, get it faced this way. My 1, 2, 3, 1, 2, 3, 1, 2, 3. So that is an S configuration because it's counterclockwise. It is sinister. Okay. Finally, we've got, or sorry, that was not that one. My bad again. It's this one. Now number 7 is this guy right here. Again, I'm only going to take off these 2 because you only ever really need to take off 2. We know this one is the alcohol, or this alcohol is position number 1 because it's attached to carbon, carbon, and oxygen. So we've got this structure so far. We know our oxygen is out front. We know our hydrogen's to the back. This one's attached to a carbon, a carbon, a carbon, a carbon, 3 hydrogens, a carbon, and a hydrogen. This one is going to lose priority-wise to this one. So we've got 1, 2, 3. 1, 2, 3. Rotate it so 1 is at the top. It goes 1, 2, 3. That is an R configuration. Okay, that was a whole lot of stuff, but again, each individual step is not that much work. It's just the fact that you have to do this little step 3 times, figuring out that you need to do it, figuring out what type of alkene, I almost said carbene, of alkene that you're talking about here. You needed to figure out what this group is called. It's just a whole bunch of little stuff to keep track of. So now that we've got all that, let's go ahead and name it. So first things are going to be all of this and the trans identifier out front. Exact order, I think there is technically a rule, but I off the top of my head don't even know what the rule is, so I don't expect you to know what the rule is. So we're going to go ahead and we're going to do parentheses. Make sure this is on camera. Sorry. Parentheses. Trans, comma, 2R, comma, 5S, comma, 7R. Close parenthesis. So that's all of those identifiers listed, but we still have our actual listing of our pieces here. So it'll be 5 ethyl pent. Sorry, I don't know. I've been on a pent kick lately. Non 3-ene or non 3N, because we also have our 2,7 diol. Trans 2R, 5S, 7R, 5-ethyl non 3-ene 2,7-diol. Sounds like I just stutter stepped through that because there's so many gaps in it, but I'll rewrite it a little more clearly because I fumbled a little in there. Trans 2R, 5S, 7R, 5-ethyl non 3N27-diol. There we go. All right. So again, that's a lot. It took quite a while to actually solve the problem. It's going to take you a good bit to solve some of these. So you really want to make sure that you're getting all your practice in and that you feel confident being able to do these in a relatively quick amount of time. You are going to have probably at least one difficult one like this on the test that you're going to have a whole bunch of components to worry about. So make sure you get pretty good at that. If you have any questions, please let me know. In the meantime, this is Mr. Diamond signing off. Hope you have a good rest of your day, everybody. Look for the name to structure video coming pretty soon after this or attached to this as well.